Hello everyone, I'm Sugat Pawar, working as an assistant professor in the Department of Electronics and Telecommunication Engineering of AISSMS Institute of Information Technology, Pune. In this video, I'm going to explain the working principle of SR flip-flop. This is the logical diagram for SR flip-flop. As we know that it has two inputs and two outputs. Inputs are S and R, that is set and reset. Outputs Q and its complement Q bar. Using 4 NAND gate, we design SR flip-flop. There are two inputs, so number of possible combinations will be 4. That is S and R both will be 0. Next combination is both will be 1. And next, any one of these two inputs are 1. So let us see what will be the next state for each combination. First of all, S and R both will be 0. So S is equals to 0, R is 0. Both are inputs to the NAND gate 1 and 2. We know that any one input of NAND gate is 0, then output of NAND gate is 1. So output of first and second NAND gate will be 1. Now we cannot find out the output of third and fourth NAND gate. We have to wait for second input of these two NAND gates. So for that, we consider Q as a 0 value. So this 0 is given to input of this NAND gate 4. So output of NAND gate 4 will be 1 because we are providing 0 as an input. So Q bar is 1 here. Q bar is given to input of third NAND gate. Now the input of third NAND gate will be 1. So output of third NAND gate will be 0. This will be the next state. Q is first state, present state, and Qn plus 1 will be the next state. So Q is 0. In next state we are getting same value, that is 0. What will be the value of complement of Qn plus 1? So 0 is given to input of this fourth NAND gate. Output of fourth NAND gate will be 1. Means we are getting again same value. Now we'll change the value of Q. Instead of 0, we'll put 1 here. So Q is equals to 1 now. So 1 is given to input of fourth NAND gate. Output of fourth NAND gate will be 0 because we are providing 1 as an input. Both the inputs are 1. So output is 0. This 0 is given to input of third NAND gate. Any one input is 0, then output of third NAND gate will be 1. This 1 is given to input of fourth NAND gate. Output of fourth NAND gate will be 0. Means here we can say that whatever value of Q we are going to put, you are getting same value in next state. So this state is called as no change state. So S equals to 0 and R equals to 0 is called as no change state. Now we'll find out the output for S equals to 0 and R equals to 1. S value is 0 here. So output of first NAND gate is 1. Output of second NAND gate will be 0 because we are providing 1 as an input. Now here we can say that out of third and fourth NAND gate, fourth NAND gate gives first output because we are providing 0 as an input. So it will not wait for second input. So Q bar will be 1 here. So 1 is given to input of third NAND gate. Output of third NAND gate will be 0 because we are providing 1 as an input. This 0 is given to input of fourth NAND gate. Output of fourth NAND gate will be 1. Again, if you provide 1 to the input of third NAND gate, then next state will be 0. Means every time we are getting Qn plus 1 is 0. So whatever the value of Q we are going to put, Qn plus 1 is always 0. So that's why this state is called as a reset state. Now third possible condition is S equals to 1, R is 0. Now S equals to 1, so first NAND gate output will be 0. Second NAND gate output will be 1 here. Now out of third and fourth NAND gate, third NAND gate will gives output because we are providing 0 as an input to third NAND gate. So it will not wait for second input. So it will directly show you Q equals to 1 here. This 1 is given to input of fourth NAND gate. Output of fourth NAND gate will be 0 here. This 0 is given to input of third NAND gate. Output of third NAND gate will be 1. Again, if you provide 1 to the input of fourth NAND gate, then output of fourth NAND gate will be 0. Here, if you put any value of Q, every time next state is 1. So this state is called as set state. Now we'll see the last state, that is S equals to 1 and R is also 1. So output of first and second NAND gate will be 0 here. Now if input of third NAND gate as well as fourth NAND gate is 0, then output of both the NAND gate will be 1. But it is not possible because we are taking the value of Q is 1 and Q bar is also we are getting 1. Means complement we should get 0 here, but we are getting here 1. So this state is invalid state. So this is the drawback of SR flip-flop, which is overcome by JK flip-flop. So that will see in next video. Thank you.